we're on. Right, this week's homework was a factor theorem and a binomial expansion. I don't know why I did that. So, use the factor theorem to show that x minus 2 is a factor of f of x, and hence find the exact solutions. What do we do? If we're using the factor theorem, it's quite a simple start, isn't it? So what's our first step? Do f of 2. Good. Oh no. I may have not actually aligned the board yet. Wait there. Oh, please, I love that. Okay, now we go to work. F of 2 is 2 cubed minus 2 times 2 squared minus 3 times 2 plus 6. Oh, so exciting. Is this going to be 0? 8 minus 8 minus 6 plus 6. It is. Therefore, x minus 2 is a factor. Good. Couple of marks for using the factor theorem correctly to begin with. Hence, find the exact solutions of the equation. Right. We've got one of the factors, so we need to find the other 2 factors. So there will be a quadratic factor as well, won't there? Now we can do this however we choose. Well, you could do this with long division, couldn't you? Or you could do it with some kind of formal comparing coefficients method. Or you can just think it through. This is x cubed, so this must be x squared here to multiply with the x to give us x cubed. Here's a plus 6 at the end, so this must multiply with that minus 3 that's there to give us plus 6. In the middle, we have minus 2x squareds. That's already given us minus 2x squared. So x times this term must give us no more. And let's check the x. We've got minus 3x from there, so minus 2 times that must also be 0. So that's it factorised. There isn't a middle term, it's just x minus 2 times x squared minus 3. I've written the same line twice. And it said, hence find the exact solutions of the equation. Well, if f of x equals 0, we have x equals 2 from up here, and we have x squared minus 3 equals 0 from the other factor, and if x squared minus 3 equals 0, x equals plus or minus root 3, and there are the other 2 solutions for it. 6 marks. It was a genuine past exam question. 6 whole marks. Great. Part 2, question 2, was binomial expansion stuff. Now, this is, Will have liked this question. This is one where actually the other method for doing it is slightly quicker. But we didn't do the other method. We concentrated on a plus b to the n. So we'll see how we do it that way. If we're doing a plus b to the 11, and we're after the first 3 terms, that's not an awful lot they're asking us for, is it? So the first term we know is always a to the 11. The second term, well actually we know enough about this to know that the second term has a coefficient of 11, doesn't it? Because that's how Pascal's triangle, for example, always starts. So that would be a to the 10b. And then the third term would be a to the 9b squared as the 2 terms. And if that's the case, then we've got 9 and 2 appearing there. It must be 11 factorial over 2 factorial, 9 factorial as our other factor. And so that's a to the 11 plus 11 a to the 10b plus, that's 55. 55? A to the 9b squared. And then it would go on. We were after 1 minus 5x. So a is 1, b is minus 5x, so that's 1, plus 11 times minus 5x plus 55 times 1 times minus 5x squared plus blah blah blah. And that is, did you get this? 1 minus 55x plus 25 times 55, which is a number greater than 3. What is it? Don't just look at me as if I'm supposed to do this in my head.
1375.
Thank you. 1375 x squared. And then it would go on. Did you get 1375? Do we agree with that? Brilliant. Remember that the mistake that people make here is not squaring all of the minus 5x. And even then, once you've done that, squaring the 5 but not remembering it was negative and ending it with a negative sign there. So be really careful you don't fall into that trap. Hence, find the first 3 terms of this. Well, this, for part 2, all this means is that we are multiplying the thing that we've just expanded by 4 plus 3x. So that's, 3 plus 4x. So that's that times 1 minus 55x plus 1375x squared. That's a 5 at the end. So, as we imagine what would happen if we multiplied this out, we would start, would we not, with a 3 by doing the 3 times the 1. So we'll start with number 3 at the beginning. Then if we think about the x squared, the x terms here, we would have 3 times minus 55 and 4x times 1. So we would have minus 165 x, and we'd have 4x times 1, so plus 4x. So we'd see how much x we'd get out of that. And then if we think about the x squared terms, we would have, we look at x squared, we'd have 3 lots of that, and 4x times that. So we'd have 3 times 1375, which is a number 4125. Is that right?
Yeah.
Didn't quite believe it. And then we'd also have, where is it? So what we've done? We've done that one times that. We'd have that one times that. So that would give us 220, wouldn't it? And then it would go on, because all the other terms after that, anything else that we multiplied would give us something bigger than an x squared, an x cubed or beyond. So the answer is 3 minus 161x plus 3, what is it, 3905 x squared, and then we go on. And there, for the final 3 marks is our answer. Okay. Any questions? Brilliant. And that's maths.